So we are still in three-phase wiring. In three-phase wiring, as we said last week, we have two types of wiring. We have a 3-wire and a 4-wire. We said when it's a 4-wire, it means that we are going to tap the red, the yellow, the blue, the three phases plus the neutral. So it will be star connected. It will form something like a star. This is a very important topic because
You are currently the only person in this conference.
Salad,
Yes.
tena umepotea?
Ni connection ilipotea.
Nilisikia inaniambia I'm the only person. Sawa, tuendelee.
Sawa.
So the main, that is the mains, which is always a 400 and stepped down or 400 for single for three phase and 300 and 230 for single phase supply is derived from the substation or transformer. The transformer secondary windings are connected in star as shown in the figure. So the star point provides a neutral for the system. That is the most important part of the star, is to provide a neutral to the system. The star point is earthed by the supply authority. So it is normally earthed by the Kenya Power. Our supply authority in Kenya is the Kenya Power and Lightning Company. So when we look at this diagram, you can see this diagram. Figure 1 illustrates a typically three-phase 4-wire distribution system. Note the star point and neutral of the transformer. Our secondary winding is earthed. So the phase voltage, you can see UF. This is the voltage of each phase conductor with respect to the neutral conductor. It is illustrated in figure 1. The value of each phase is 330. So sometimes we have 340, but the international standard is Salad.
For this, is it a star or a delta?
This is a star. You can see it is like a star. You see,
Yes.
this is the winding. This is for the one phase. This is for another phase. This is for another phase. So it is star. It is star. So you can see the neutral. The way the neutral is tapped. The neutral is in color blue. You can see the neutral is tapped, and the earthing is in color green. But the phases are here. Phase 1,
Yes.
that is line 1. Phase 2, that is line 2, and phase 3, that is line 3. So you can see them.
Yes.
Yeah, so we proceed. So this is the voltage of each phase. That is phase is represented as the voltage of each phase with respect to the neutral conductor. It is illustrated in the figure 1. The value of each phase voltage is 330 volts AC, root mean square. The line voltage this is the voltage between any two lines, e.g. Between line 1 and line 2, line 1 and line 3, and line 1, line 2 and line 3. It is illustrated in the figure above. So the value of each line voltage is 400. Sometimes it's 415. So it depends with the frequency that is being used. If we use a frequency of 60 hertz, 60 hertz will get 400. If you use 50 hertz, we get 415 volts for the three phase. The three phase voltage is very important because it is used to load very high loadings, like now for the industry premises, for things like the posho mill, for things that use a very high load. Now, a three-phase 400 volts 4-wire supply is used for industrial and commercial loads. The industrial loads usually demand more power than the domestic loads, and more power can be supplied by a 400 voltage. That is the three-phase supply that is possible with the 330 volts single-phase supply. So it is possible to take the following supplies from a three-phase 400 volts 4-wire system. So a three-phase 400 volts 4-wire supply, which is used for unbalanced 300 three-phase load as required. They require a neutral. So the three-phase 400 volts 3-wire. I said 3-wire is delta. Delta looks like a triangle. We talked about that last weak. Delta, that is the 3-wire supply, does not have a neutral wire. But for the three-phase star, it enables the tapping of the neutral. That is why it is normally liked and mostly used, which do not require the neutral. We have the two-phase also. Remember, in the market, we also have two-phase transformers. So the two-phase also, their phase supply, that is the two-phase, that is the 2-wire supply, supply which is used for loads such as welders, correctly required as the one-phase for 400 volts. So we have the single phase now is here is one-phase supply, which is used for loads such as lamps, heaters, and computers. These are now low loads. Now let us look at this. This one is for the one phase tapped. Now we are tapping, loading one phase. We are loading one phase, that is, it is tapping from maybe one of the phases. You can see it is getting the load. This one is getting the load from this. This one is getting the load. These are now single tapping, balancing the loads. And this one is getting its loading from here, from the line 3. Load 1 will get its live from line 1. Load 2 will get its live phase from line 2. And load 3, the same will get from line 3. And then the neutral is here. Every load has to be attached to the neutral. And then when it is now two-phase, this one is getting two phases, that is, it's getting line 1 and it's getting line 3. So you can see how they supply. So when you're balancing the node, now the one that is using 3 load without neutral, that is the 3 phases. This one is tapping. You can see one of the red phases, the line 2 is here and line 3 is here, but it does not have a neutral. And we also have another load that now has a neutral. We have one there, we have another one there, and we have another one there, and the neutral is there. So all the balance load that we talked about here, yes, Salad.
I'm asking the yellow line.
Do
The yellow,
you have a
yes.
Uh,
I think see red, blue, yellow, and neutral.
yes, those are the faces that we have. But hapa tumezirepresent na hizi colors. You know, that is color coding.
Yes.
But in this case, take line 1. You can see where line 1 is, the L1.
Yes.
That will be our red. It's normally red, yellow, blue. So the one that is indicated as line 2, you can see L2 will be our yellow, and L3 will be our blue. So we are. This is just color coding for this diagram so that we can be able to see. We need a lot of colors. You see, the color blue here represents the neutral. This is just coloring, but you simply know that this is line 1 is for the red, line 2 is for the yellow, and line 3 is for the blue. And this is the neutral. The neutral is normally tapped from the center of the line where all these faces meet. You can see the line 1 face. When you see this resistor, meaning that those are the resistances inside the line, that is the supply line, the cable itself. So this is line 1, this is line 2, and this is line 3. Is that okay?
Yes.
Okay. Any other question before we proceed?
Nilikuwa nauliza the yellow phase we can use like a neutral. You can tap from line 1 and line 2 and you get a single phase.
What do you mean, Salad?
I'm saying if you take the red phase, line 1, and you take line 2 yellow to the consumer, that 2 wire, you already make the single phase.
You already gotten no. For you to get a single phase, you only tap. You know, Salad, I don't want you to confuse yourself. This is a 3-phase, but it is a 4-wire. What do we mean by 4-wire? We mean by 4-wire because it has the one line. You see line 1. You see L1.
Yes.
I think you guys can see the resistors. This is a resistor. This is a resistor, and this is a resistor. Are you seeing that?
Yes.
That one is supposed to be representing the resistance for the phases. So this is the first phase, this is the second phase, and this is the 3 phases. Phase means live. When I talk of a phase, it means live. So for a 3-phase, it has 3 live wires. Are we together with that?
Yes.
For a three-phase, we mean we have 3 live wires. So when I say there is a neutral, so where these 3 live wires are, so it is called a three-phase because it has 3 live wires. And when we have a two-phase, it means we have 2 live wires. When it is called a single phase or one phase, it means we have a 1 live wire. So for this supply system, it has a 3 live wires. That is line 1, you can see its resistance here. Line 2, you can also see its resistance here. And then line 3, also its resistance is here. So when the 3 wires, when the 3 lives meet at this point, that is called a star. It is called a star point. You can see that arrow. Let me zoom out so that you guys can see. This point here is the point for where the 3 phases meet. It's called a star point. So the star system is meeting at this point, and we can now tap our neutral from this point. At the same time, we can tap our earthing. This is the earth. The earth is in green. We can tap our earth from this point. So when we explain about the loading, so today we were talking about how to tap the loadings. How are we tapping the loadings? From the supply. So these are the loadings. We have 3 types of loads. Let me take you back here. We have this type, the possible loads that can be supplied from the 4-wire system. The first load that we can supply is a 3-phase 4-wire supply that is used to supply unbalanced 3 loads in as they require a neutral. So you can see here, this load here plus neutral. You can see where my red is pointing. I hope you guys are seeing. This one. This is now the 3-phase neutral. So the 3-phase, it means that this load, I'm zooming so that you can see, this load that is in a rectangular box, it is written for 100 volts 3-phase plus neutral. It is tapping, when we say that it is 3-phase, meaning it has to have 3 lives, 3 live wires. That is, the first live wire is from line 1, that is in red. The second live wire is from line 2. You can see it being tapped here. I'm zooming so that you guys can see well. The second wire is here. It is from the black, that is line 2. The third live wire is here. It's from line 3. So it has the 3 lives. And then it is getting a neutral from here. Remember, our blue here was representing our neutral specifically for this diagram. So our neutral is tapped here. So this one is tapping 3 phases and a neutral. And then we have another load that can supply without a neutral. So this is an example of a load that is tapping without a neutral. So this is here. And the kinds of loads can be now the ones that are used for heaters, the ones, things like motors, 3-phase motors. So this is an example of that load. It is just tapping the lives. So you can see this one is tapping the phase, just 3-phase from this line. The second live phase is from line 2. It is tapping it from this point. And then the third phase, it is tapping it from this point to the load. So you see this load is not getting the neutral. So it just gets the 3 phases. So like what you are saying about tapping 2 phases, now we can get a 2 phases load. No, it is tapping 2 phases load without a neutral. It is not a single phase. It is called a 2-phase. And that is why in the market we have a transformer that is a 2-phase that can be able to tap only a two phases from the system, that is from the supply system. This is the load that is tapping the 2 phases. When it is tapping the 2 phases, meaning it is tapping the 2 lives, live 1, and it can either take line 2 or line 3, but this one took line 3. So it can balance. So it takes live 1 and live 2. So it is not a single phase. It is a 2-phase. It is called a 2-phase because it is tapping 2 live phases. This is a live phase and this is a live phase. At the same time, we can have one that is taking a live phase, a single 1 phase. Remember, all our single phases must have a neutral. So this one, we are tapping this. This is a single load, tapping one of the lines. This one are now lighting, like now we say the lights, the computers, the iron boxes, and all those. They tap the single phases. These are now what our sockets normally have in our homes. It has a phase. You can tap it from one phase. Another load, you can tap the second phase. Another load, you can tap from there, another phase, so that you can balance. This is called a single phase. It is called a single phase. Sorry, let me go back there. Let me go back there because we had not finished. Yes, here it is. You can see it is called a single phase because it is tapping one live wire. This is a live wire. This is a live wire being tapped here. This is a live wire being tapped here to this load. This is another live wire being tapped here to this load. So up to there, I need you to ask any question before we proceed. Everybody to talk. Moses, ask a question. Salad, you can also ask a question. Now ask questions before we proceed. Now about loading. We were doing loading using the three-phase supply. Yes, or people are okay? Salad, can I assume that
Yes,
people are okay?
yes.
So guys have understood. We can go to the next slide. Three-phase color code. Now we have the color codes here. The three-phase color coding. Now, in order to standardize cable colors, we have the coding has to undergo two major changes. That is since 1990. In any system installed before that year, it is possible to encounter the old color code, which were the line 1 was red, the line 2 was yellow, and line 3 was blue, and N was neutral, and E, which is the earthing, was green. But we have, some countries have changed. But in Kenya, most of the supply phases we have in our country, Kenya, are still in this color code, the first color code, which is line 1 with being red, line 2 being yellow, and line 3 being blue. That is why we call it red, yellow, blue, and then neutral being black. That is for our country. This is what we are still using. But other countries have changed, and they're using line 1 being brown, line 2 being red, line 3 being yellow, and the neutral being blue. And then the E being the earth. Now, another change made in 2006 for other countries still, that is line yellow, line 1 being brown, line 2 being black, line 3 being green, and the N being the neutral being blue, and the earth being yellow stroke green stroke yellow. So if you meet all this in the network, our country is a free country. It buys cables from any other place. It imports cables. We manufacture cables ourselves. So you can get all these codes in the field. When you get to the field, you will be able to distinguish. So if you use this to be red, so normally, remember, we normally have these tapes in being bought. We have the yellow tapes, we have the red tapes, and we have the blue tapes. When you have used all these codes, because the one that we are used to is the red, yellow, blue, make sure you use your tape and indicate that this is the red tape, this is the yellow tape, and this is the blue tape for the system. Now, the division of loads between phases. Division of loads between phases. Now, when connecting single-phase loads on the three-phase supply, care should be taken to distribute the single-phase loads equally between the three phases so that each phase carries approximately the same current and the neutral current is kept as low as possible. Distributing the three-phase loads equally across the three-phase is known as balancing. Now we know we have something called the load balancing. That is the load, we are balancing the load. And then lighting load of 18 barriers. And then a lighting load of 18 luminaires would be balanced if 6 luminaires were connected. That is between each of the three phases and neutral. So typically layouts of the small to medium industrial installations are shown in the figure. Let us go to the figure. So this is balancing the loads to the circuits. So the figure shows a main supply taken intake point in a small industrial installation. Yes, Salad. So you just found yourself to have, okay. And then we can show the main supply intake point in a small industrial installation. The main supply is taken through an isolator to the bus bar chamber. From this chamber, other sub-main isolators control and supply to various other sections of the premises. So isolator number 4 is shown supply of the three-phase distribution board, which is in turn feeds the final circuits. So you can see this is the submains, this is the bus bar for the main isolator and the main incoming. This one is also used, this is called a block diagram, and then we can also convert this to a schematic diagram. So we can see the main sub-main isolators are here to the loads. Then we have a one to the loads, and then the another one distribution. These are just the bus bars that are distributing to the loads. These are to the load of the three-phase distribution board. The final circuits to other loads are there. Now we are the figure 4 shows particularly exposed main supply intake point in a small industry installation. The main supply is taken through the 300 amperes fused switch to a bus bar chamber. So this chamber consists of a suitably sized copper bars isolated from each other and from earth. This bars mainly somebody is writing something. Okay, so Ladi said I repeat this slide. You can see this slide, it's here. The main supply intake point, this one is just the industrial distribution of the isolations. These are the isolators. Isolators are like the switches that are used to isolate the supply. We can see how they are constructed. We can see this one, the isolators, the main isolators has to be there. The incoming cable, this is the cable that is used to tap the power from the supply. And then we can see this is another isolator. These are isolators, the sub-main isolator. An isolator is like a switch that is used to supply to the other loads. So these are the switch. So you can see isolator 1, 2, 3, and 4. This is the isolator to the first load, isolator to the second load, that is load B, isolator to load C, and isolator to load 4 or load D. This now, and then you can have the final subcircuit. So the subcircuits will be tapped from. Isolators are switches or the protective devices where we have the fuses and the switches that are able to break the circuits or to cut off power in case of any danger or in case power is not needed. That is the control circuits. So those are what we mean by isolators. Isolators are like switches or main switches that are used to cut off power. Okay, we proceed. This one I said is now power being taken for small industries to distribution boards. Now the main supply is taken through the 300 ampere fused switch to the bus bar chamber. This chamber consists of a suitably sized copper bars isolated from each other and from earth. These bars may be a circular or rectangular cross-section. This layout shows the lighting, power, and heating loads separated from each other as is from this case. So the heating loads can be seen to be supplied from the bus bar through a 100 ampere switch fuse to a 10-way three-phase distribution board. So this board may be used to supply 10 three-phase loads or a mixture of three-phase loads and a single-phase loads. For example, it may supply 8 three-phase loads and 6 single-phase loads. So you can see it here. This is a distribution board. This is a distribution board again. This is now the phases, the three phases, the way they are supplied. So this is now the switch. This one is from the main, that is the three-phase four-way supply. This is like now from what is coming into the meter board before it gets into the distribution board. This is they have the three fuses. We normally have at the meter board, we have the three fuses. This is the first fuse for the line, first live, the second fuse for the next line, the third fuse for the third line. And then this is the neutral. You can see the neutral is tapped from the pole. This is the neutral that is normally supplied by Kenya Power. We say the neutral is supplied is given by the supplier, it's given by Kenya Power. This is the fuse for line 1. You can see the live 1 is here. The fuse for line 2 is here. This is our line 2, our next phase. And the fuse for line 3, our next phase is here, and our neutral is here. And then now we have this is a fuse or the isolator that we talked about. These are the isolator fuses or switches that are going to the distribution board. This is the isolator for distribution board number 1, isolator for distribution board number 2, isolator for distribution board number 3. And then you remember that this isolator it is still taking the 3 phases. At this point, all the distribution boards are still tapping the 3 phases. And now you can now distribute and say, now let this phase now take this line maybe to the lighting circuits. These are normally for like storage or storage buildings, where you can say that let me subdivide this building to have maybe this one phase to go to this building, the other phase to go to the other building, and that is a power circuit, that the heating circuits are here. You can see how the correct phase rotation, that is polarity, this is now balancing of the phases. Connect line 1, line 2, and line 3 either to left or right of the top or as appropriate. Now the 3-phase distribution board, how is it installed or how does it tap the wires? Now we said that figure 5 shows the internal connection of distribution board consisting of the 3-phase MCBs and the 3-phase RCBOs. It may be used to supply the 6 balanced 3-phase loads, 3 of which require RCD protection. So the 3-phase RCBOs are here. We have the first line. We said the breakers have all the lines. We have the first line. We have this breaker, that breaker, and that. So this is the 3-phase supply for the mains, and this is the distribution board. So the 3-phase MCBs are here. So this is the input and the output, the input and the output fuses. 3-phase and single-phase distribution board. You can see figure 6 shows a small industrial distribution board. It is being used to supply a mixture of single-phase and 3-phase circuits. So the single-phase loads, it is supplying a single-phase lighting circuit and a single-phase motor circuit, both of which are not provided by the RCD protection. It is also supplying 2 single-phase socket circuits which are provided in the RCD protection. So the 3-phase loads are here. It is supplying the 3-phase motor circuit, which is not provided by the RCD. Remember, RCD we said is the residual circuit device for the protection. It is also supplying the 3-phase socket circuit, which is provided with the RCD protection. So the neutral connection, it is supplied with 3 neutral paths. It is of the utmost importance that the various circuit neutrals are not mixed up in any way. So a wrong neutral connection will result in the tripping of one or other RCD. It is possible to supply the single-phase loads through a 3-phase RCD, which would simplify the arrangement of a good deal. However, it is not recommended to supply a mixture of single and 3-phase loads through the one RCD. Then the reason for this are beyond the scope of the 2-phase. Now the neutral connection for any load not protected by the RCD must be from the main neutral bar. And then again, the neutral connection for any loads protected by the single-phase RCD must be from the single-phase RCD. The neutral connection for any load protected by the 3-phase RCD must be from the 3-phase RCD. So those are the rules of connecting the distribution board. Then note that there is only one circuit supplied through the 3-phase RCD, and then the neutral connection for this circuit can be taken directly from the 3-phase, that is the RCD, if a separate neutral bar is not provided. We have a small industrial distribution board. We have the main neutral bar. We have a single phase is here. The main earthing terminal is here. Now this is how the distribution board looks from inside. You guys, when we go back to school, when we go back to the university for face-to-face for the practical classes, you will be able to see this distribution board. And make sure when you are in the workshop and you are with your teacher, whoever teacher will be taking you for practicals, make sure that you are able to see these ports where you can put your circuit breakers. So this is the main circuit breaker. The main circuit breaker for the mains or the main switch is here. The one that is used for the switching, the MCB. That is from the main neutral bar. You can see it here. And then you can see now the three-phase motor where it is being loaded. The main switch is here. And these are now the other breakers that are tapped. You can see how the other breakers are. And the neutral is being fed to all these circuit breakers. You can see the other circuit breakers to the sockets, to the phase, the three phase is here. The sockets, you can supply as many sockets as you want. And you can see the main switch is there. And these are the supply from this is the supply from the pole. And this is the earthing bus bar that is there. Now the high breaking capacity fuse. The high breaking capacity fuse, also called the HBC fuse, are suitable for industrial insulation and motor starting circuits. They can distinguish between the starting surge and the short circuit. Their operating characteristics are such that they can disconnect short circuits much more rapidly than any other protective device. So the HBC capacity, that is the HBC fuses, are very important for the three-phase because they act very fast. For example, the HBC fuse can clear a high fault current in 0.01 seconds. You can imagine how fast it is. So it can avoid fire breaking or burning of devices like motors. So while the mechanism of the circuit breaker would take 0.1 seconds to operate. Now, this type of fuse is also known as the high rupturing capacity or the HRC fuse. Its fuse element is enclosed in the robust cartridge of the heat-proof material. The cartridge is packed with chemically treated silica sand to quench the which occur as the fuse element ruptures. So this ensures that there is no fire risk. They did not deteriorate with age. So the construction of the a typical HBC fuse is shown here. Now look at it and the parts. We have the lead, the lug. This lug is where now we're going to use it to fix the nuts. The fixing slot is here. The end cap is there. The low melting point. These are fuse elements that are here that can melt in case of short circuit. And then we have the reduced section is here, the ceramic tube and the silica sand. So the barrel of the HBC fuse is made from the high-grade ceramic to withstand the mechanical forces of heavy current interruption. The end caps are here, or the tags are plates and that are ensuring good electrical contact. And the fuse element is accurately shaped and machined to give precise characteristics. Most HBC fuses are fitted with indicator beads which show when it is ruptured. So disadvantages are it is very expensive. Very expensive. Advantages are it discriminates discriminate between overload currents and short duration, that is e.g. the motor starting, and high fault currents, that is the short circuits. It also consists of consistent in operation. It is reliable. They have a speed operation. They operate at a very high speed. They have a fusing factor as low as 1.25. They have no risk for fire. They are capable of breaking very high value fault currents. And then they are easy to replace. They are very easy to replace. And then they are available in a wide range of current ratings. Another fuse that we have, the Type C. The characteristics of this Type C MCBs is supplying loads which are relatively high switching surges, e.g. the electric motors. Protection is provided by the neutral tripping device. So the short circuit protection and high value, that is overcurrent protection, is provided by the magnetic tripping device. So Type C characteristics must trip magnetically between the 5 and 10 times. So the rate, and it must trip thermally between 1.13 and 1.45 times its rated current. So example of the 20 ampere type C characteristics, we have the short circuiting protection as high. Then we have 20 times 10 amperes, that is 200 amperes. And then we have from this example, it can be seen that the type C must operate between 100 to 200 amperes instantaneously. Overload protection, that is the thermal, that is 20 times 1.1, that is 22 amperes. From this example, it can be seen that type C must operate between 22 to that ampere after time delay. So the type C MCBs are available in different current ratings and breaking capacities to suit the particular installation. So you can see that the most common plug and socket arrangement for the general purpose use indoor in the 13 amperes metal clad type. It is robust and will provide individual protection for the connection of various portable appliances. So the plugs and sockets are there in industries, and the appliances you can see. The very simplistic view of this and several other factors involved, such as frequency and current ratings. The more common varieties of such run are as follows: appliance inlet couplers. These are plugs that are used for loading. So the plug and socket coding are here. Now the common plugs and socket plugs outlets. You realize that only these plugs you normally be meeting them in the industry, because these are the plugs that are used for high three-phase volts, high loads. So it is 16 amperes, 110 volts, a two-pole earth plug and surface mounted plug. Note the position of the earth pin in the plug, and then it is in the 8 o'clock position. But remember, these will match up with the earth sleeve in the socket. These are which is in the 4 o'clock position. So you can see it. This one now at the 16 ampere 230 two-pole earth plug. And then we can see these are 16 volt a 3-pole earth plug. So the 3-pole is given by the red. So you can see how they look like. You will be able to meet these things in the industry, and you will see them. These are how they look like. You can see this one is a 3-pole neutral earth. You can see these are 3-poles. We have the 3-poles, neutral, and earth. So we have the 5 of them. And the surface mounted interlock switch socket. For safety reasons, the plug cannot be inserted or withdrawn when the switch is in the on position. Again, the earth pin in the plug and earth sleeve in the socket are both in the 6 o'clock position. So you can see that. The sockets are still there. Industrial socket circuits. So the socket circuits in industrial premises may also be wired in a radial ring formal. In either case, the load on the circuit must be assessed and the cables and protective devices must be capable of supplying this load. The earth socket should be individually protected against overcurrent. This cable used must have a current carrying capacity equal to or greater than the rating of the overcurrent protection. So sometimes calculations are done to be able to get the rating of the sockets. Now the distribution board and these are just the codes for the industry. And up to that point, can I have any question? Can I have questions? Can I have questions? Can I hear people ask questions? Humphrey. So somebody is saying something. Salad. You have no question. Humphrey, Peter.
Yes.
Yes. Salad, you're okay.
Yes.
What about others?
I have no question.
Peter is okay. Humphrey anasema, yeah, we have no question. Okay, so I'm happy you guys are understanding. I want us to go through this one very fast because our time is almost half. And then we have the three-phase voltage waveform. You can see the three-phase voltage waveform, how they look like, how the supply system is looking like, and the circuits. So these are the three phases. We have the red and the yellow and the blue, how they move. And then these are the circuits, the fuses. This is the three-phase, this is the resistor of the three-phase systems are there. The Y connection is here. Y is also called the star. As a lad, remember now what we were saying, the red, the yellow, and the blue, and the neutral is tapped from the center. So the star is also called the Y system. So in your exams, you might see the name Y written. So the Y also means star connection. And the delta connection is also here. The delta is like a triangle. The delta connection, this is the delta connection. It's like a triangle, triangular connection. That is the supply for the delta system. Can see the delta system is there. So I think I'm done with what I was supposed to do today. So this one we just go through them very fast. Three-phase voltage generation and the three-phase sequence, three-phase connection and balanced loads and unbalanced load, that is the Y and delta, and the relationship between the power three-phase circuit, the measurements of the circuits are there. And then the objectives are to become familiar with the operation of the three-phase generation, the magnitude of the phase relationship connecting the three-phase voltages. The three to now to be able to calculate the voltage of the currents, the three-phase connected generator and the load. Three-phase voltages, generator and the three-phase sequence. You can see them there. And these are some calculations which you will not do at your level, but when you get to the diploma level, you will be able to do the calculations and the sequence. You'll be able to understand the positive sequence and the negative sequence. Uh-huh. The balanced load, that is the power loading, is split equally among the three phases. We said that, and we saw that in the diagrams. That is the loads on the phase A and the phase B and the phase C. The current is equal on all the three phases. That is balancing. Unbalanced load, that is when the load impedance of the three phases is not equal in magnitude or phase of both the phases. Balancing of the loads also, you'll be able to see them later. I will not take you through the calculations because it is not you will not take it at your level. So up to that point, I want us to stop there and have a break of about 20 minutes. And in the 20 minutes break, I want you guys to go to the discussion and write something there. I realize some people are not participating in the discussion. I want people to participate in the discussion and write something there. So do we have any questions before we can come to the end of this lesson so that we have another break of 20 minutes before we can come back again? Can I have questions? Or a comment if there are no questions? Can I have comments? Salad?
Yes.
Any comment, any question?
Okay, class is good and enjoyable. And if I may ask, the bus. Bus it is the many wires or what? Your bus
Busbar is just like a rail. Busbar is like a rail. Unaona wakati una connect. Have you ever seen ukiangalia consumer unit? Huwa penye huwa
Yes.
tunaweka. Have you ever seen a consumer unit?
Yes.
Penye huwa circuit breakers zinawekwa. Before uweke circuit breaker, si kuna kwanga na kachuma hapo. Penye unaweka hiyo circuit breaker, penye una fix hiyo circuit breaker. That is called the bar. Bar inakaa kitu kama hiyo. Penye hizo breakers huwa zinakuwa hooked. That is the bar. When you talk about the bus bar, that is the bus bar. Where you can hang or hook the circuit breakers. Ama unaweza kukanoa kama ni ya earthing bus bar, ni ka rail tu kako hapo na iko na kashimo penye unaweza fix na nut unaweka all the earth wires and all the maybe neutral bus bar pia iko hivyo, and the live bus bar penye unaweza weka all the lives by using the circuit breakers. Is that okay? Huh? Watu wako sawa? And here questions.
Tuko sawa.
Kama mko sawa, I want to give you a break of 20 minutes. Hiyo 20 minutes muingie kwa discussion, write something. We are going to come back again with a workshop organization class so that we finish the class again. So you guys, I'm giving you a break of 5 minutes, of 20 minutes, sorry. Muende mkunywe hata kachai and then we come back. So if there is no any other question, I'm ending the class.